Okay, it says I'm live. Hopefully I am live. Here we go. Welcome everybody. Jason's Electronics Repair. I'm hoping this is working correctly and we will save that. Okay, so yes, you have my keyboard on the screen because I'm working on something with the switch. I just need to do a few things. Hello David, how's it going? I wasn't going to stream today, but I came up with something interesting that I was just messing around because I'm waiting for some equipment to arrive, and um, yeah, I'm waiting for some equipment to arrive, and I was messing around, and I came across this interesting thing. Hey Tiago, how's it going? Um, so um, first of all, I planned on a live stream tomorrow morning with some new equipment that was supposed wow, words hard, that was going to be here today, and they told me in the middle of the night that in an email that it was going to be delayed in shipping. So the stream that I had planned for tomorrow morning is going to be delayed until Tuesday. So because they won't deliver on the weekend, and Monday afternoon, evening is when I'll get what I need. And then I have to do some stuff. So the stream that would normally be on Saturday will be on Tuesday. But this switch is interesting. Um, so this switch is dead. It's got a dead CPU, but it still charges a battery, and I'll show you that right now. So if I plug a battery, my test battery on here, and I plug in my OEM charger with a current meter, you can see that you can barely see that. Hold on. It's crazy. Okay, well, you can see it's drawing 427 milliamps. Now, I can assure you this doesn't have P13 on it and it is dead, but it's drawing 400 milliamps. It is charging the battery, and that's what I will use this for, if not a donor board. So, there we go. That's that part. So, we know it's charging a battery and it draws current. Now, what I have is on my power supply. Hey, Phil, how's it going? So, we confirmed this charges this battery. And what I have here is I have my power supply set up with a DC jack to a USB-C cable, or USB-C female. And if you watch the left uh, on the power meter of the power supply up top, the one that's 5 volts, 3.2 amps. If I plug in the USB C port and I turn on that channel, I get a current draw of 100 milliamps. Um, okay, that's doing something totally different than it did a minute ago when I was testing it. So let's disconnect the battery and reconnect it and try again. Okay, so I turn the channel. Okay, so there you go. It's drawing 470 milliamps. So it's charging. It's charging the battery on the 5 volt um, cable. Now, here was here's where I thought it would be an interesting test, and I messed around with this and I got weird results. So this is what I'm going to show you. So I'm going to turn off channel 1, okay? And I'm going to unplug this cable because this cable has two lines coming into it, a power and a positive. The positive goes to pin 4 on the right, pin 4 on the left, and the same on the bottom. And then it has a ground. So my question was, if I hook up a on channel 2, I have some injection probes here, and if I touch pin 4 on the port and ground on the port, I should be able to inject 5 volts and show charging. So I'm going to turn on channel 2. Channel 2 is now on. It's not drawing any current. So I'm going to put this on there. And as you can see, I'm injecting 5 volts. I'm not getting any kind of amp draw. I'm not getting any kind of amp droppage in the port at all. But here's where it gets weird. Okay, so let me turn that channel off. Here's where it's weird. If I take this USB-C adapter right here and I plug it into the port, this is weird. I plug it into the port, I turn back on channel 2, and I touch this and this. It'll inject the voltage through those 2 points and draw 450 milliamps. So, hey Red, how's it going? No, it's not BQ. BQ's fine. This is a dead switch. The CPU is dead on this. But as you can see, I'm injecting voltage through pin 4 and ground. So, just a minute. Yeah, Teflon is horrible for heating. Yeah, be careful. We use Teflon at my old job, and you have to be very careful with that stuff. So again, if I pull out this port here, and I try to inject the same voltage again, I get nothing. But you know, just by having this port plugged in here, I can inject voltage into the pins, which is weird, right? So what is happening with this being plugged in here? That's the question. Like what is happening that is allowing me to inject voltage when this is plugged in, but not when it's not plugged, when it isn't plugged in. So that's where I stopped with the testing, because I thought this would make it interesting. You know, this is I figured it would make an interesting stream. There's nothing wrong with the port, and there's not a fault here. There's no fault with this. The charging circuit's fine. M92 is fine. BQ is fine. The downside of this is it's the CPU shorted and P13 is bad. But this does it on different switches. So there's no damage traces and things like that. So there has to be some kind of continuity here, or some kind of communication when the port knows there's something plugged into it through something called USB detect. And how does USB detect work? Well, it uses 2 pins on the, and I lost my mouse. Seriously. Let's take the distracting 2 things off the screen. I lost my mouse. Hold on. I have to find it. There it is. So, yeah, I'm not sure. We're gonna figure that out. But let's pull up a USB detect circuit on USB-C. Let me open that up. If I can find it. Here we go. Let's type in USB-C port. Why do they always make me want to buy the data sheet? I don't want to buy a freaking data sheet. Hate when they do that. All right, here's one right here. I'll bring this up here. Okay, so let's look at this here. Let's look at this on the monitor. So this is your USB port here. You have your 2 outer legs that are ground, okay? Then here is your V-bus. This is your power, are on A4 and B9 and A9 and B4. So that's where I was injecting power. I was going through ground and the test point that connects to this. Okay, you have your D plus and your D minus that interfaces with USB 2. Now, here's where it's interesting. If you flip the port, if you flip the USB-C port over, ground, power, and D plus and minus are in the same orientation in both directions. Okay? If you flip the port over, TX2 and TX1 swap, and then RX2 and RX1 swap. And then you have S bus 1 and S bus 2, they basically swap. And you have CC1 and CC2. It's one becomes VCON, which is your USB power delivery communication, and the other one is called is CC. So depending on which way the port is plugged in, it will be one will be VCON and one will be CC. So our two USB detect pins are B5 and A5. So that is where we will look at for that. I'm going to put this in the switch document. Hold on, let me save this image real quick. Let's save image. Let's save it in switch document. Yeah. Let's save that. That's a good image. All right, let's switch back to the camera and do some tests on this. Let's see. Okay, so. All right, so let's check chat real quick. That is very strange. Is one of the pins being pulled down low inside the port? I'm not sure. I haven't got that pin. Yeah, I'm gonna check that in a second. That's exactly what I'm gonna check. Like a short to ground. So B5 and A5, they don't swap. Symmetric. Yeah. Yeah, that's what I was going for. But anyways, VCON becomes CC and CC becomes VCON depending on how you plug it in. So circuit switches in. Yeah, which way the port plugs in. Yes, and that's part of the power delivery system. And we know the power delivery system works on this board because it will negotiate for 15 volts and it will work with or without the thing plugged in. So what is going on when this is plugged in that I get that I can do it one way but not the other? So let's get the meter back up and put it in continuity mode. I would say diode mode, but I don't know. Continuity is going to be easier to follow. My meter, I have to change a setting in my meter to do diode mode correctly. Okay, so we have continuity mode on the screen. Now I know that VCON is right here. So one of these is VCON and one of these is CC, depending on which way you plug the port in. So first, let's check to see if they're connected in any way, shape, or form. So there is 1,761 ohms between VCON and CC. Okay, let's plug in this port and see if there is a difference. And it is exactly the same. Let's see if there's a difference when a battery's connected. You know, there may not be an answer to this today. It has to be M92, which did. Yeah, but what does it matter? What's telling it that that it's got something plugged in? Something's got to be going low or have a different resistance. Hey, GMO, Fourth Wizzy, Red, Liam, John, how's everyone doing? Wow, a lot of people in chat today. That's crazy. So let's check it with a battery connected. And what we have here, so we're not getting any difference with in ohms between the two, VCON and VC. And if I flip the port over, I'm not getting any difference either. So what is giving us that? So let's do some measurements with the power connected. So I'm going to plug this in. I'll put the power back on the screen. And I'm going to turn on channel 1, which is the DC jack that is going to give me a charging symbol. So Doing well for the crack of dawn. Yeah, I get up early, guys. I've been up since 2 a.m. and it's 7:43. So we're doing 40. Wow, thank you, David. Wow, yeah, I definitely gonna buy some labels. I greatly appreciate that. Again, if you're coming late, I normally stream on Saturdays, but stuff didn't show up. Why can't I ever find my mouse? Too many screens. Let's go back to DC voltage. Okay, so we got DC voltage. So check A5. I can't really check B5 unless I plug something else in. Oh, Tiago, thank you for becoming a channel member. Alexander, how you doing? Well, it's like, well, a lot of people. Well, this is getting crazy. Look at that. We all thank Phil for this. I'm sure most of you came from his channel. Okay, I have too many test probes on the bench. They're getting all mixed up. Okay, let's get the voltage injection leads out of here. Okay, so like I said, we're charging a battery at 450 milliamps. It's on the screen. I want to check the voltage at VCon. I doubt there's going to be anything. No, nothing. Is there anything between those two? Huh. And then here. That's weird. I get 355 millivolts one way, negative 355, but if I go the other way, I don't get anything. So something is going on. So someone suggested that I check A5 and B5. Yes, I do get up at silly times. Don't get nervous now. Listen, this is a pure scientific expedition. I don't get nervous on scientific expeditions because I always look like a fool, so I don't have to worry about looking like a fool. That comes naturally. So let's swap some stuff around here. Let me unhook this. Let me get a test board here that I can test the pins. So let's get this board here. This is a test board that I can plug in one side and plug in the other, and it has my pins on it. So the top row is the B pins, and the bottom row is the A pins, which is super confusing. So yeah, so that's how that works, guys. So this is the most confusing one ever, but top row is A, the bottom row is A, top row is B. So I come in here like so, plug that in, and turn back on my power supply. It's going to do something. That's fantastic. And if I go to ground here, and I go to A4, should have 5 volts. If I go to this pin here, should have 5 volts. This pin here, 5 volts. This pin here, 5 volts. I shouldn't have anything on D minus or D plus. No, anything on. Okay, so that's voltage. No, that's voltage. So this is CC right here. And then this is VCon or vice versa. So nothing. So I'm not getting any kind of obvious thing that it's doing with it plugged in. Interesting point though, if you look at the board up here, you pick up 5 volts from this test point. You pick up 4.1, you pick up battery voltage. So if you want to see what the voltage is going into the battery, check this test point right here. So, I mean, some people go across the meter, the coil like that, but this test point right here will tell you what's being pumped into the battery. So that's pretty good. Um, little bonus tip there on that. So you actually learn something from this one. So what is this test point? That's 5 volts right there. So this test point is 5 volts. I check D plus and D minus with any kind of voltage. Let's check it again. Nope. No. I don't want to really mess with D plus and D minus because that's what's shorted on this board. I just kind of want to mainly focus on the charging circuit. So if I touch here, this point, I get 2.8 volts. Why 2.8 volts? What's battery voltage? Battery voltage is 4.1. What is it if I take it off? Four volts. Okay, so probably gonna have to reset that. Worked. So if I check that again, I should have 4.1. Why is this one? Is that just going through a divider for a sense pen or something? That's weird. Why is that 2.8 volts and steady at 2.8? Oh, that's going to take further investigation. So let's see here. Mr. Tiago in his green. We have, since following Phil, I follow a lot of people he's recommended. Yeah, Phil's done a good job on recommending people. CapTech, CapTec is another great channel, along with Micromage Repair. They're both good channels too. They fix a lot of stuff a lot faster than I do, but they also see a lot more stuff than I do. I have 2 switches coming on Monday with all that other stuff, so. Yeah, the connector board, I have a few different connector boards. I have this one here that has B test points on one side and A test points on the other, so that's basically worthless. And then I have this one that all the switch data is based on, that plugs in and shows you where everything goes on the board. I got this from Amazon, so USB-C breakout board. At least in the meantime of all this testing, I'm charging my test battery. Yeah, A5 and B5. Well, see, I mean, if it's A5 and B5, I should be able to pick something up on A5 and B5. I mean, there's B5, and it's basically, I mean, it's well, speed is pretty accurate, and if it's doing that, it could be getting a signal through, like, what's, there's an A5. Okay, A5 has 429 millivolts on it. That was one of our pins. And then it was this one. Has 1 millivolt on it. So that wasn't on. So if we look at our A5 pin, I was measuring the wrong pin before. Told you I'd be a fool. So this is our A5 pin. This is our CC1 or VCon. And it's got 429.28 millivolts on it. So if I flip this charger over, let's read that pin again. So let that stabilize, okay? So if I read that pin now, I don't get anything. But if I read this pin, I get the 423 millivolts on it. So is M92 taking the power delivery information and sending a signal out through VCon back to the charger to tell it how much power to deliver? So 422 millivolts. I'm assuming that's flat DC. I don't have my oscilloscope hooked up. Come on, people. Wow, Fort Twizzy. Fort Twizzy, my bad. Totally butchered that name after you became a channel member. Oh, yeah, see the coders already found the emojis, and Fort Twizzy found the emojis. Thank you, guys. Oh, I think I can get more emojis. I have more. At a certain amount, I get more emojis, depending. Phil should have a lot of emojis he can upload. I need to change the background to black on the other 3, apparently. But Phil has options to have a lot of emojis, I bet. But thank you all for being members. I appreciate it. Y'all gonna make me want to stream a reball or something. So, you tell people to use the oscilloscope. Hypothetically speaking, if you swap the APU and NAND with a different board, this one should be working. No, honestly, I think this one is a short on the CPU, not in the board itself. I think it's an actual short on the CPU, because if we go out, we turn this off, and we go out of here, and I go back to continuity mode, which means I have to find my mouse. You should make the mouse like bright neon green or something. That would be fantastic. So we got us in continuity mode, and so if I come up here and drop stuff everywhere, that's fantastic. Oh, it's such a mess here. I'm so sad. And if I touch this capacitor here, it's short on both sides. That's the P13 capacitor. And if I come over to this side and I touch this capacitor, it's short. And look, P13 is not even there. So it's not even P13. So what happened with this? Let me get the scope out here so you guys can see this better. I will flip through the scope in a second, Phil. Don't harass me. So if I come over here to this, there's a video on this, but I will clarify real quick what's going on with this board. So scoop. There's the scoop, Phil. I didn't forget to switch it. Phone keeps ringing. Well, it's not me, Phil. So this filter right here, this FL1 filter, was blown, and it blew the trace off, but I was able to save the trace, put a new filter on, and but it was smoked. It was smoked real bad. Check out the first video in the 1007 switch fix, and you'll see how bad that filter was blown. So if you look, that filter connects to these two. This is D plus and D minus. I don't know which one is which. I can't remember. I have it written down, but I don't remember at the moment. So that runs up to this point right here, and then it punches through the board. And if we come on this side, it punches through the board right here. So this is D plus and D minus on the other side of the board. And if we follow these traces, go under the sticker and follow it around, still following the freaking long traces. And they punch back through the board right here. And if we hold our finger there, that is right about here in this area under the shield, which is the CPU. So that is the line that got probably a good 15 volts and about 1.5 amps. But it still charges batteries, and it's a donor board now. And I may actually practice on this one with reballing CPUs. So this one's going to be a practice board for reballing and things like that, and a donor board, because donor boards are expensive and they're hard to come by. So I have possibly 2 donor boards, and then I'm not sure about one, but this one definitely a donor board. Yeah, it's still short without the NAND. If I pull the NAND off, it's still short. Yeah. Yeah. So yeah, a micro major repair told me to pull the NAND off and check it, and it was still short. So I've been searching for an eBay NAND replacement on the Switch. Possible. Yeah, I don't think it's possible either. Hey Ken, how's it going? Hopefully I didn't miss anybody else that said hello. So yeah, so that's where this is on this. So I may mess around with messing with the CPU. Let's pull the shield off. You guys are gonna convince me to do something I don't want to do. I can feel it. Oh, I'm already pulling the shield off a CPU. What are you guys doing to me? You didn't even suggest it, and I'm just like voluntarily doing it. All right. Okay, excuse me there. So let's see if I can. I don't have to heat this shield up to take it off, do I? Just come off, right? I don't want to take the whole shield off. I just want to take the top of it off. There we go. That is like royally stuck on there. Hell makes everything look easy. I mean, he's just like, oh, the shield's off. Whoa. Sit here 20 minutes to remove the shield. There we go. There's that one. I'm probably not even using the right tool for this. It's got these freaking clips here that anybody coming up with a better suggestion on taking this off? It takes a bit of prying. That's helpful. Thanks. I'm just like half tempted to desolder the whole damn thing right away. There we go. All right. Of course, it's got thermal paste on it because it knows how much I love thermal paste. I love thermal paste all over my hand, all over my new gloves. It would be fantastic for that to happen. They just really smooge it on there. They don't really careful about it at all, are they? Nothing is in its spot. Now, I want to I want to make something absolutely clear right now because Phil's going to suggest this in about 2 minutes. This is my hot air gun. My hot air gun is not on its stand, so it should be on. So therefore, I have no hot air, so the CPU will not get pulled off, Phil. So I know you want to suggest pull the CPU, but I can't. I don't have hot air yet. It's not hooked up all the way. So I'm reorganizing. I got a whole new area of workspace that is cluttered with garbage at the moment, and I am making room over in this area for my Hacko iron and stuff like that. So yeah, so right about this area here is where that D1 and D2 come up. Never actually pulled one of these off at home. Only seen other people do it. No, I think that'll fit on my hot plate. I bet you that will fit on the hot. Pull this. Seriously, I just told you I don't have any hot air. I go get the hair dryer. Should I go get the hair dryer, Phil? Let me go get the hair dryer, and then we'll pull the CPU. Yeah, that's what I'll do. Make Phil happy. We'll break out the hair dryer, and we'll, pull the CPU off. Yeah, that will fit my hot air. That will fit my little. No, if I don't want to heat it up and like assist it or whatnot, it's possible. Preheat the board a little bit. Not a bad idea. Not sure. So, very interesting. So, yeah, that would fit. I don't know if it would be helpful, but now that I know it fits on there, I'm going to try it with the hot air. It makes sense to get it off. Yeah, pull it with what am I going to pull it with? Seriously, you know how much ruckus would be made me trying to hook up my hot air station just to undo it for when the stuff comes. So I have this soldering iron, and that's it at the moment. The only way to know heat gun and a hammer. I don't even think I have access to a hammer where I'm sitting. No, that's buried behind. My toolbox is buried behind a bunch of stuff too. So I didn't plan on streaming today. I planned on a stream tomorrow when my stuff showed up, but again they sent me a message this morning saying that there was a delay in delivery and it won't be here till Monday because they don't deliver. That company doesn't deliver on the weekends. So I had everything planned for a huge unboxing stream tomorrow, and now it's going to be postponed till Tuesday. So I don't have. I have a video on there for members. Nothing real exciting. I don't have a lot of member videos that are any good. I have 2 switches coming on Monday that I can't even mess with until I get this bench organized. So I'll start filming them probably Wednesday, and I'll do the unboxing stream on Tuesday and film the workbench tour and all that good stuff. So I'm gonna revisit this USB-C port, and I'm gonna hook up the oscilloscope and the waveform generator, and I'm going to shoot back 422 millivolts on VCon and see if I can inject 5 volts then. So if I could, realistically, if I injected 5 here and 3 in, 4. What? Okay, I thought they were connected. And I blasted 422 to the other one. I wonder if I can inject voltage that way. Because technically 2 probes taped together with the right voltage, I could hit both points with one thing. So it's worth a shot. I'm going to try it. Stick it in the oven at full temp. I have a toaster oven that I dry boards out in after I run them through the ultrasonic cleaner, and then I put them in a toaster oven at 180 Fahrenheit until they dried out. Because I'm weird. A X-Acto knife blade and slice through all the balls. I use scalpels. I don't use X-Acto. Hammer and a chisel. It's like a hot knife through butter. I have a butane soldering iron. You think that would work? Yeah, do it with a butane soldering iron. I'm sure I can get it to. I'm sure I can reflow all the balls and all the chips with the butane soldering iron. I don't think there'll be any damage to the connectors or the board or anything like that at all. That would be a good experiment, but not on this board. So, switch number 1, the first one I got that I can't get working. Where is that at? I think it's right here. This is the one that I pulled the max IC off to reball. And I'm going to reball that. The plan was tomorrow morning, but I'll do it on Tuesday. If I don't reball it on Tuesday, I'll put a new chip on there. And then this board charges, but it charges at a lower rate at slow charge, no matter what the battery level is. And after doing extensive amount of research, I think that it could possibly be in RCM mode, and I'm going to take a look at that. I'm gonna get this back to where it turns on and doesn't show anything on the screen, and then I'm gonna check it with the RCM thing. I got this little RCM loader. I don't know if it's useful, but we're gonna try it. And we're going to see if we can bring back number 1. If I bring back number 1, I'm going to keep it for sentimental purposes because it's my first one. And I thought it was a lost cause. So, yeah. So there's number 1. So, then I have 2 sitting over there waiting to sell. Number 3 and number 2 are waiting to sell. They're on my eBay store, link in the description. So, I reflowed the oven. I used to use a reflow oven and at my old job, and it was fantastic. Someone called video with the LTT logo. That's funny. Reflowed laptop in the oven. Read that one. Yeah, I want to see the NAND reballed and the Wi-Fi chip reballed before I do it. Yeah, you were telling me that, Phil. Yeah, no, on the reball, I don't have any hot air. I don't have any hot air today. I'm supposed to have hot air today, and I was supposed to have hot air tomorrow for that. I don't even think I put reball in the description of the video. So, I'm going to call it here, guys. Really nothing else I can do. Thank you guys for watching. Thank you to all the new members. There is a video up there, Tiago, for Twizzy. Was there another member? Yep, new members too. So thank you guys so much. And oh, David, thank you for the donation. Yep, I remember you donated $2.99. Thank you so much. I hope everybody has a good day. Thank you.